Most of the time when we're working on computers, we're trying to do 10 things at once. We got our, 10 tabs open on the internet. We have our word processor. We have our music playing. If you watch the video on DOS, you'll notice that DOS could not do multiple things at once. As soon as you try to open a second program while having the first program open, it would crash the entire system, which of course would be annoying for us modern users who are used to multitasking on the computer. Well, it turns out that dealing with multiple processors, even one processor at a time, there are many tricks that the OS will employ so that you as a user gets a really smooth experience. So, in order to process that data really efficiently, to jump between tasks, to solve really difficult tasks, here are some of the techniques that computers will use, specifically that the OS will use to process that data, process those tasks. Sometimes we call those tasks jobs because it's pretty much work that the computer needs to accomplish. So we have multitasking, multi-threading, multi-processing slash parallel processing. Slightly different. We'll discuss that. And then we have memory management. So let's take a look at multitasking. So that's basically running multiple programs at the same time. Something you should note is that one processor, one CPU, one core, they can only do one thing at once. But they have a cool trick, which is called time sharing or context switching, where it'll switch between tasks so quickly that from the user's perspective, it's doing two things at once. So that's one trick that a CPU will use to make it appear right like it's multitasking. So it's actually doing one thing at a time, but it's doing them so quickly that it seems like it's knocking out two apps at once. But most modern CPUs have multiple cores, multiple processors, so they actually employ really advanced tricks for executing those jobs and finishing those tasks that you ask the computer to do. Specifically, that the software right is telling the computer to do. So we have multiprocessing and parallel processing. So that involves multiple processing units, two or more. So that could be a CPU or it could be multiple cores inside of a CPU. Remember, a core is just a mini processor that's inside a bigger main CPU. So multiprocessing is when you have all the cores, all the processors working on separate tasks at the same time. So that's real multitasking. You're actually processing multiple things at once. Now, let's say you have a really big task, a really difficult job that the computer needs to solve. That's where you go to parallel processing. So, parallel processing is when those processors work together on the same task. So, it's going to split the workload across all those different processors so that they complete the task super fast. Now, of course, today most PCs have multi-core CPUs, so they have the ability to do either multiprocessing or parallel processing. So they're going to recruit all their workers, right, all their processors to solve these really difficult problems. Another trick that they have is memory management. So remember, RAM is that memory that is directly tied to the CPU to solve those really, really intense problems, those really time intense problems. So, for example, you have the issue of working on two apps at once with one single core. Well, it's going to have to switch back and forth, right? So it's going to be leaning on the RAM to solve those operations, to save that data, uh, to get rid of it, right? So it can make room for the next operation. Same if you're playing a video game, right? You're going to be dealing with lots of graphics data, so you need to throw that through the RAM very, very quickly. Well, sometimes you run out of RAM. RAM is an expensive, limited resource. It's probably one of the most expensive components on your computer. But there is a trick that a computer can use when it does run out of RAM, and that's a virtual memory. So it'll actually go to that storage hardware that we discuss, the SSD, for example, or the HDD. So it'll treat it as a RAM memory. Now, of course, as we saw with some of these permanent storage hardware, they're not as quick as RAM. But when push comes to shove, you run out of total RAM and you still need to solve that task, it's still a good idea, right, to lean on some of the other hardware. Even though it's not designed for those fast processes, it'll get the job done. And it'll make sure that you can move forward right onto the next task. So that's virtual memory. So it's like the computer is pretending that that storage hardware is RAM when it's really not.